positive with something that irregularity. If some because when we manufacture certain materials, we don't know what's happened inside. Okay, sometimes it has dented. Okay, even not on the surface, but in that material itself. So this fatigue, uh, that material will experience a fatigue failure due due to that irregularity or discontinuities of that materials. Okay, this stress concentration factor, the contoh dia, stress concentration factor, because this is the fatigue stress, okay, then concentration factor. Okay. Maknanya apa? Tadi kita ada, we have that SN kan, we have this SN. Then we have SN, so the time multiply with many factors, load factors, all the factors. Same as this fatigue stress. Okay, we have the fatigue stress. Okay, fatigue stress may experience bending, axial. Okay, okay. So this fatigue stress will be influenced as well by the factor. So what the factor, call it concentration factor, means the stress focus on that that factor, uh, that irregularity or discontinuities. Example is the shaft, for example, the shaft. If we design the shaft, it's quite difficult that we just have one straight line of the shaft. No. Okay. So normally we have this, okay, we have fillet. We have fillet. So macam ni lah. Sa, si. For this fillet. Okay, this is concentration factor. This is concentration factor. Even some holes, for example, here, to fix with other device, for example, here, lubang. Yeah. So this will, the more stress on this fillet, the holes. So that after we calculate the stress, okay, the stress, then we need to multiply with this concentration factor. Okay. So the stress time with concentration factor. Okay. So then we will get the corrected, the real. Okay, the real. This is not unreal, tapi itulah before multiply with corrected factor. This is the real one. Okay, means after multiplying with the concentration factor. So now we learn what is the concentration factor. What is the concentration factor? So the symbol of, so the fatigue stress concentration factor from the existence of irregularity or discontinuity in material is defined. So the formula is given. For bending and axial, actually the same. Okay, this KF, this stress concentration factor for fatigue stress, this is the formula. KF. So it has two parameters, two variables that we need to get the value, which is Q. Okay, Q is notch sensitivity. Then we have KT. What is KT? Static stress concentration factor. Static stress concentration factor ni Okay. Okay. This QKT from the table. So we have to read the table. Okay, this Q just different form. Okay, different form of this one. Okay, different form of this one. Okay, as I said before, okay, this is just symbol. Sebenarnya this is symbol. Kita tengok, if you see that it's O, O, O. O, O ni, ini, in this one, this one O O. Okay. Before multiplying with the factor, maknanya you get direct from when you calculate. Okay, when you calculate, you get this fatigue stress, the original. Okay, this once you have multiplied with the factor, then you will get the real. Okay, the real. That's the difference. Okay, that's just symbol. Okay, so this A, kalau you tengok this A alternating. Di depan ni kan, sigma, how to read A. So sebenarnya you boleh guna buat any symbol lah. Okay. So this A used for alternating. Another A, axial. Sama juga this one A, alternating. Then this used for bending. Just to differentiate between axial, the axial and bending. Kalau torsion memang dah different lah, tahu. Sama juga this one. So this O ni, O is the original. Okay? If you don't want to use the O, it doesn't matter. Just to make different between before multiplying and after multiplying. Okay. Okay, this is not notch, the value of Q, notch sensitivity, notch Q. Okay. This is the graph. The graph dapat daripada mana? Jadi tengoklah, semak balik dekat, refer to the okay, ada dekat situ. Okay. Okay, tengok balik dekat data book for test 1. Data book for test 1, 2.3 fatigue, stress, concentration factor. So equation 2.2, 2.3 is the equation for KF. Okay, so you will find the equation of KF above this graph in that data book for test. So how to read this one? How to read this one? Okay. Why Y, let's say Y. Okay, this notch. X, so you have value of notch radius. Notch radius. Notch radius means if this is shaft, so this shaft normally not the design of the fillet is not like this. So because this is the stress concentration. So it has the fillet, it has the value of radius. Yeah. So this is the R value. Notch radius. Okay. So above is inch and then below is millimeter. If you see in the graph, okay, this for steel. Okay, steel BHN, Brinell hardness. Okay, Brinell hardness. Okay, BHN. Then ultimate strength. Okay, so the value is first ultimate strength. SUKSI. Okay, in KSI. Then the next one is Brinell hardness. Brinell hardness. Okay, it has two types of two category. One is bending and axial. So bending and axial just use the first is value. Okay. Kalau you tengok, if you see in your table, there's no circle lah, red circle. So this red circle you have to do in your data book too. So you just do the circle. So this used for bending and axial. For torsion, so this end of value. Let's say the notch is 3 mm. Okay, 3 mm. And then the specimen, okay, the notch, no, the radius of this one is R is 3 mm. And SUT is 140. Okay. Then it has the specimen experience just bending. Okay, it has bending. So 140, 140. So you see 140 here. This 200, 140. 3 mm. So this is 3 mm. 3 mm value. Kan? Dapat 143 value disebabkan oleh bending, caused by the bending. So you just then you go direct to the y-axis, then you get the value of Q 0.9. So you jangan ambil 140 at torsion. If 140 in torsion, 140, so should be in the middle here for torsion. So you have to different graph. You have to make a guess. If good is interpolation between two graphs. Otherwise, you could just a guess if the ultimate strength doesn't show in this in the line. So 120, 180 in the middle is 160. So 140 like this. Okay, the value. But this for torsion, since this is for bending, there's been bending. So you have to ensure that you have to take the identify the right ultimate strength. Okay. All right. Okay, the next ada contoh. Sebelah ni ada contoh. Ini contoh lah. So you boleh tengok, you could see, you could read the examples. One is QS, torsion, and one is bending. Okay, next is KT. Okay. Next is KT. What is KT, class? Static stress concentration factor. Okay, static stress concentration factor. Tadi notch, ni static stress concentration factor. So KT, you nak tengok kat mana, the same data book, so it has a different shape. Kalau macam ni, kat sini lah, this type of, this one. And the one, this one. Okay, where the fillet on the shaft. Okay. How to read? How to read? Okay, it has an example here. Okay, Y is KT. X is R over D. And the graph is D, capital D, okay, divided by small d. What is capital D and small d? Smaller d, okay. The capital D here, okay, it does show three graph here. So if in the middle, just guess, make, I think just guess, not, you could do interpolation. You could do interpolation between the value. Between the value, you could do the interpolation. Okay, this is an example. If D is 60 and the small d, capital D is 60 and small d is 40, so you get the value of 1.5. Then if the R is 2 and the smaller d is 40, so you get the value as 0.05. Okay. So this, you see that this is due to torsion. Okay, it has axial and bending. Okay, I show you the real graph. Kalau tak tunjuk nanti kan. Okay, ni. Okay, this is Q. This is Q. Q. Stress concentration, KT static, sebab nama dia static, dia berada di static. Okay. Since the name is static, this is static area, this is static. Static. Since the name is static, it is in the chapter of static. This one. Okay. Okay, KT. Okay, KT. So they use norm. Okay, in your is norm. Norm mean original. Okay, this is the they use max. So the real one after multiplying with KT. This is for static. This is for static. The value, this one is for static. Okay. But for the fatigue, so we have different equation for because we need to use this KT in order to calculate the fatigue stress concentration. I just want to stress here, they have different type of loads. One, you see, this is bending moment. And the one is axial load. And the one is torsion. So you have to use different graph, different reading with the different types of load. Okay. So this is this one. Just two types. The fillet is in the middle between small diameter, big diameter, big and small diameter. So another one is here. It has also bend moment and also axial loads. Then also the torsion. Okay. The shape of the shaft is different. Where the stress concentration factor, here is the fillet. Okay. The notch, the fillet here. So in between, same. So it has another shape as well. Okay. Combine, just one shape. And also different, and the previous one is a shaft, a round one. So this not. So different rectangular, it also has different graph. And different load applied. Okay, ni pun sama, ada lubang dekat tengah. And pun sama juga, the load different form. Okay, this as well, say different one, KT. Okay. So you have to choose the right, first the right load, the shape, and also the load applied. Okay, cara nak baca dia. Okay, you get the, first choose the graph. So here is D over, capital D over small d is equal to 1.5. So you see that there's no 1.5. So it has 1.2 and 2. So in between 1.5. So we just guess somewhere 1.5. Then R over D is 0.05. So this is 0.1. So each unit is 0.01, 0.5, 0.05 is 0.05. So just go up, just make a line. Then 1.5 is between 1.1 and 2. So, 1.2, somewhere here, somewhere in between. And then just make the horizontal line to the KT, so you get the value. So the value may between, this is 1.7. This 1.7 is between 1.7 and 1.6. So in between. So in between. Okay. Okay, ni yang tadi lah. Tadi. So we just multiply the original, this stress concentration factor, dapat, multiply. So ini kita dapat the real one, the real. Okay, kelas ada soalan? Sebelum kita ada combine. Okay. Combine maksud dia kita ada mean stress. Biasa ni lah kita ada axial bending torsion. Okay. So macam mana kita, how we could combine all this one. So the combination of all the stress, okay, we call it equivalent. Here is equivalent, QE. One is equivalent means, and the one is equivalent alternating. So sebab tu the symbol use E for equivalent, A alternating, E equivalent, M means. That's a symbol. Okay, we need to combine EN, AN. So later on when we draw we calculate the safety factor. So this value will be used. Okay. Okay, for the equivalent alternating stress, used from distortion energy theory, von Mises. By combining, okay, the axial and bending, and then torsion and square root, you will get. For the mean stress, using the maximum principal stress using Morse circle ataupun using this equation, okay, then you will get the equivalent means bending combined. Okay. So this one just using this without O. Ni without KF. Yang another equation is with F. Dah darab lah. KF. Kita kira KF. Combined stress with consideration of KF. That's different. Okay. Okay, next. Lepas ini, barulah kita boleh kira safety factor. So after this, we calculate the safety factor. So because we will use this value this value will be inserted to the safety factor equations. So the safety factor equation, we normally use two types. One is Langer, and the one is Goodman. Okay. One is Langer, one is Goodman. So this is the equation for Langer safety factor. Okay. A alternating means, and then you use yield strength, yield strength. This is yield strength. This is ultimate. This is alternating. This is means. So actually, this is the Langer is developed from the yield strength. Sebab tu, if you see that the line is from yield strength to yield strength. But for Goodman, this is Goodman. So you have to identify for the alternating stress. So you have to use Sn, then this ultimate. Okay, so below this line, safe, above fail. This is infinite life, this is finite life. For the Langers, so if we draw the Langers, okay, Langers, if we draw the Langers is SY yield strength. Let's say this is SUT. This is SY. This is SY. So this is Langers. Okay. This is prevention from. If you see the Langers, it's not the fatigue failure prevention, but it's this is the yield. Yield means before it is in the plastic condition. Okay. So we have to design our parts should be if we know the number of cycles, so we could estimate, we could calculate the SN. Okay. So we have to design our product, or we should design our shaft having infinite life, so it should be under this line. So by calculating the sigma A, sigma M, then we could calculate the safety factor. Okay. Okay, this just showing the different fatigue strength. So let's say this SUT. So this SN, this SUT. Okay. With number of cycle, different number of cycle. Okay, this is safety factor based on Goodman criterion. Okay, next. Okay, this is the as I explained to when the Langes and Goodman line being plotted in one graph. So you will see that here. So if, for example, you will find the sigma m here, sigma m1, and this is sigma a1 here. Okay. So the parts will fail, or the shaft fail due to the Goodman. Okay. But for the Langes, yield line is still safe. Okay, class. So I think that's all for fatigue theory. So all the fatigue theory. So okay, let's redo examples. Let's redo examples. Simple examples. Sebab banyak sangat equation kan, banyak graph kalau tak ada sample, example pening. Okay, tapi example ni you could do it by your own sebenarnya. You just see, okay, I just explain a bit on the examples. Okay, a component is subjected to a maximum cyclic stress of 750 megapascal and minimum is 70 megapascal. So maksud dia apa? So dia ada macam ni lah. Kita buat. So you ada. So this is 750. This is minimum 70. $750 maximum, minimum 70. Okay. The steel from which is manufactured has the ultimate strength SUT, 1050 megapascal. And it has the endurance limit of 400 megapascal. And the fully reverse stress at 1000 cycle is, this is the value of, kalau you ada this one, 1000 cycle. If you remember that you ada this one, this is 1000, this is 1 million, this is 0. Okay, so this is Sn from experiment prime. So this is 1000. Actually, fully reverse stress is from experiment lah. Roger Moore experiment. So 1000 cycle. So 1000 cycle. If you see from the graph, kalau you tengok baik the graph, so this is S3. Okay, ada 1000. So this S3 is 750. S3 dia ni, the value of S3 ni 750 megapascal. Using the Goodman fatigue failure criteria, calculate the component life. Okay. Component life, maksud dia berapa, bila dia fail. Okay. When this part will fail. Okay, the fail ataupun ada infinite life. Okay, kat sini kalau kita tengok, if you see from this equation, from the Goodman, okay, because we need this one. From the Goodman theory, okay, we need this one. So we need to calculate sigma A and sigma alternating and means. Then from this equation, this is fatigue stress. Okay. Fatigue stress. Fatigue strength of that material, of fatigue strength of that material. Okay. Then we plot the graph, this value. So these 2 points have the same number of cyclic life. So you have calculated the fatigue strength here. Then plot the graph. And the value is here. After that, in order to calculate, because the equation, the question is how to calculate the component life, means the numbers of cycle. So we have to use this one, numbers of cycle. Using this all the formula, then you will get numbers of a cycle is 2.544 times 10 to the power of cycles. Okay, just insert the value of Sn, S3. Just insert the value, then you will get the value of N. Yeah. Okay. question is, okay, calculate the component life. Okay, another example, I think you could just go through this is just the cases. Okay, the next one is just the cases. Okay, class. I think that's for fatigue theory and very simple example. Very simple example. Almost 2 hours. Any questions for the fatigue? So nanti kita akan buat beberapa example lah. So I have uploaded the question, two questions. So you could try if you want. Okay, you could try if you want that questions. And then we could discuss in more examples. In two examples in our next class on Sunday. So ada soalan kelas? Ada soalan? Saya rasa sampai sini je lah. This is the only theory lah. All the theory on the fatigue. So the most important dalam fatigue ni, pertama, definitely you have to know how to read the graph tables. And also the other one is how you determine the load applied on the shaft or the parts. Then you will determine either bending or axial. Once you have determined bending, you dah kira bending, axial, kan? Kemudian you have to calculate the concentration factor, kan? Concentration factor. Kalau ada concentration factor itu. Kalau tak ada, you could just combine all the bending and axial together. Okay, combine. So once you combine, you know that either it is mean stress or alternating stress using that formula. Okay, if it has the concentration factor Kf, then you need to calculate the Kt and identify the Q. Okay, and then for the Goodman, so you have to calculate the corrected endurance limits. So for the steel SN, from experiment SN, equivalent to 0.5 times ultimate strength of the material, of the steel. Okay, of the steel. Then you have to consider all the factors. Kan CL, CT, and all C surface tu lah. Okay. So you have to take for surface, take from the graph. And so it has three category. Okay, bending, axial, and torsion. So you have to have the right chosen. So from that one, after that, multiply with, you know that zero kan, you got the zero to, one is the original times the Kf, so you will get the real one. Okay, we get the real stress, static stress. Kan, sigma axial sigma alternating and sigma means kan, dua itu kan, time dan Kf. So daripada situ you dah boleh kira safety factor. Okay, that is the process. The process quite long sebenarnya. So it relates each other. So when you could identify step by step. Okay, while doing the process. Actually, the target is if safety factor. Okay, the safety factor. Kalau tengok safety factor, let's say Goodman. kan, safety factor. So dia ada SN. So dia ada as sigma A, sigma min. So this sigma A, sigma min ni, this is real. Selepas after you multiplying with the stress concentration factor. Maknanya you have to multiplying with KF. The original, so that is KM original. Original, you calculate from either moment, bending, or torsion. That is original. So the original time KF, so you get KM, sigma M, and sigma A. So this SN ni deal with the factor. So CL, CT, CS, and so on. Okay. This KF ni, so this is deal with KT and deal with the apa itu Q notch. This from the graph. So if you see that all the graph or all the tables, the most important is how we deal with this one. Kita akan balik kepada the basic. Kita balik kepada basic yang we need to identify bending and axial. If we determine the right bending and axial or torsion in our component in shaft ataupun another parts of our problems, so if we identify the right one here, axial and bending, so we will get the right answer. Kalau we determine the wrong axial and bending, so we will get the wrong answer until the end. Okay, that's the most important. Okay, this is just the application of determining the fatigue or predicting the fatigue. Okay, this is the most important. Is this one. This is the just application. Okay, saya tengok example sikit. Saya terangkan sikit lah. Jadi kita akan bincang. Kita akan bincang next week lah. Okay, if you see this question, The rotating shaft shown in above figures is machined from the materials. That shaft made of this material, steel. It is supported by bearing at A and B, and if F is 5 kilonewton. Okay, so kita gunakan either use Lenzi or Goodman criteria. Will the shaft have infinite life? Okay. So apa yang perlu kat sini, what is the most important is to determine, the first thing is to determine, okay, to determine which is the most critical location. Definitely pada permulaan kita kena carilah what is A, what is B lah. Kan, reaction force. So this shaft is berpusing, rotating, dia berpusing. Macam RR Moore lah, RR Moore experiment tu. Tapi RR Moore tu dia line bentuk dia. Tapi kat sini dia ada the shaft. Okay, shaft, dia rotate. So pertama sekali, definitely you have to calculate, draw the free body diagram, then identify the A, what is A, what is B. The reaction force at A and B. Okay. Selepas tu kira A and B, saya bagi just gambaran lah sikit, gambaran. Saya bagi jalan kerja sikit lah, supaya you try lah. Okay, kemudian you boleh kira moment. Dekat sini, from what we observe now, so we could identify that the moment diagram is at F. Okay. But in our mind, that stress concentration factor occurred at fillet 3 radius 3. So the failure could happen. So we need to prove that either at F will be fail or at 3. So we will calculate we need to calculate the stress, bending stress. We need to calculate the bending stress at the fillet and at the F. So make comparison. Make the comparison. Which bending stress is more, either at fillet or at F. Okay. Once we get either at fillet or at F, so we know that these types of shaft is tadi apa? Reverse bending. Okay, reverse bending. Okay, kita tahu that it's reverse bending. So reverse bending, so just draw the graph reverse bending. Okay. So from that reverse bending, we need to identify the sigma A and sigma means. Since sigma, since reverse bending, sigma means is 0, right? It's reverse bending, kalau itu refer reverse bending. Ni kan reverse bending ni. So sigma means 0. So kita hanya ada alternating stress. So that is alternating stress, what we have calculated for bending stress, that is alternating stress. Okay. So daripada situ, bila kita dah kira alternating stress, that's original. So kita kena cari, we have to calculate the real one. The real one, we need to calculate the KF. We need to calculate the KF. So when we get the KF, then we need to multiply KF with the real mean stress. Then we will get the original. Then we get the corrected, the real one. Kan? Selepas tu kita dapat cari SN lah. SN. Sebab kita, our focus is Goodman and Langer. So go back to Goodman and Langer. So apakah parameter, what is the parameter, the value that we need to calculate? Okay. Okay, I think that's all for today class. Ada soalan tak? For the theory of fatigue, nanti kita akan buat small revision lah. On the once we do the equations, we solve the equation, the question. So then we will make the revision of the theory. At least you get the overview of the fatigue. Yang saya nak ialah you have to make a hard copy for that data book tu. Data book tu you should have hard copy. So easy for you to read all the graph and the tables. Okay class, ada soalan? Definitely masih blur, betul. Memang blur. Kan, masih blur. Sebab belum buat soalan. Tidak buat soalan, baru tahu. Okay, thank you very much class. So